Hey everybody, this is Mr. Chernitsky, and this is Unit 4, Lesson 2, Parallelograms. Or, sorry, actually this is going to be quadrilaterals, not parallelograms. We're going to talk about parallelograms, but also the rest of our quadrilaterals. So last lesson, we looked at all types of polygons, including quadrilaterals and hexagons and heptagons and all sorts of polygons, but we're going to focus in on this lesson only on our four-sided polygons, specifically quadrilaterals. And what we have here is our what I call our quadrilateral family tree. So we classify our quadrilaterals into different types. And I like to think of it almost literally like a family tree, because if you look at anything that's in the parallelogram, the parallelogram is going to have its own set of properties, and those properties are going to get passed down to the rhombus and the rectangle and ultimately down to the square. So whatever we say is true for the parallelogram is true for the rest of them. Okay. We'll go ahead and start with parallelograms. What makes a parallelogram is that it has two sets of parallel sides. So you notice there's our one set and another set, parallel sides. The area of parallelogram formula is just base times height. So in this case it would be 1 foot, or we'd want to convert that to 12 inches times our height of 8 inches. So it would be 12 times 8 for our area. Which would ultimately equal 96, and our units are square inches here. Okay. All right. Other properties of a parallelogram. Opposite sides are congruent. So that means that these two, the top and the bottom, are congruent. And then the two sides are congruent. We could also say that opposite angles are congruent. So angle A and angle C are congruent. Also angle D and angle B. B congruent to DC. Let's write down those congruent sides. So AD was congruent to BC. And down here we had angle A congruent to angle C. Consecutive angles are supplementary. So what that means is that in our parallelogram, oops, let's stay consistent here. Any two angles that are next to each other are going to add up to 180 degrees. So angles A plus D is going to equal 180. D plus C is going to equal 180. C plus B is going to equal 180. And B plus A is going to equal 180. So any two angles that are next to each other add up to 180. And our last property of parallelograms, draw by diagonals. They're going to bisect each other, and if you remember what bisect means, cut in half. So each of these diagonals is going to get split in half by the other one. So those are parallelogram properties. Let's take a look at the subcategory of parallelograms. So that's our rhombuses, rectangles, and squares. A rhombus, by the way, a plural of a rhombus of rhombuses, you could also say rhombi, that is grammatically correct, whichever one you prefer. Now, since a rhombus is part of the parallelogram tree, it's going to have all the properties of a parallelogram. So all those properties that we just talked about, they are also true for a rhombus. So a rhombus, by definition, has all four sides are congruent. So, you know, the property of opposite sides of a parallelogram being congruent, well, that's obviously also true if all four are true. But opposite angles are going to be congruent. The diagonals are going to bisect each other. All those things. The formula for an area of a rhombus is 1/2 the length of the diagonals multiplied to each other. So in this case, it would be equal to 1/2 8 times 12, which if I work out 1/2 of 8 is 4, times 12 is going to give us 48. That would be our area. I'm not too concerned about you guys memorizing area of anything other than the parallelogram. Which also, by the way, would also work on a rhombus because it's also a parallelogram. So if you had the base and the height of a rhombus, you could get that as well. So diagonals bisect opposite angle, or sorry, other properties of a rhombus. Diagonals bisect opposite angles. What that means is those diagonals are going to split the opposite angles in half. And finally, diagonals are perpendicular to each other, so if we had to properly draw a rhombus here, this one's a little stretched, but your diagonal is going to form a right angle. You can see a little bit better in these rhombuses. Alright, and those are our properties of a rhombus. A rectangle, by definition, all four angles are right angles. It also has all the properties of a parallelogram. Area of a rectangle is base times height, just like a parallelogram. And its only special property is that its diagonals are congruent. A square. Well, a square has all the properties of a parallelogram. And a rhombus, because all four sides are equal, just like a rhombus, and a rectangle. So it's kind of all three things at once. Okay, let's take a look at trapezoids and kites. A trapezoid, by definition, has one pair of parallel sides. instead of two. It just has one pair. The area of trapezoid is 1/2 the sum of the bases times the height. So we have the two sides that are parallel to each other, we call those the bases. And so for our area, it'd be equal 1/2 and it would be 8 plus the other base, 12 times the height, which is 5. So if we work this out, let's see, 1/2, 8 plus 12 is 20, times 5, half of 20 is 10, times 5 is going to equal 50, and our units are going to be centimeters squared. Special properties of a just a general trapezoid. The lower base angle is supplementary to the upper base angle, so what we mean by that is this angle A this angle D, those will add to 180, and also angle B and angle C here would also add to 180 degrees. But not all consecutive angles. So only A and D and B and C. You can't add A and B together to get 180. In fact, you already tell that both those are greater than 90, so there's no way that those would add up to 180. Okay. The other kind of neat property is the length of our mid segment, which is just if we find a midpoint on either side of our trapezoid and then draw a line to connect it, so kind of like the halfway of our trapezoid. That length is the average of the two base lengths. So if AB is 20 and DC was 30, EF would equal the sum of those two divided by 2. Oops. So 20 plus 30 is 50. Divided by 2 would equal 25. So it's just the average of the two base lengths. We have a special kind of trapezoid known as an isosceles trapezoid, which has which is a trapezoid with two congruent sides, or one pair of congruent sides. Let's rewrite that. One pair of congruent sides in an isosceles trapezoid. Each set of base angles are congruent, so this one angle Z congruent to angle Y, but also at the top there, angle W would be congruent to angle X. The last property of isosceles trapezoids would be that their diagonals are congruent, just like a rectangles. So ZX be congruent to WY in this case. Okay, and that's our trapezoid section. We have one more quadrilateral to talk about, and that is kites. Kite is pretty familiar by its shape, but its actual formal definition is it's a quadrilateral with two pairs of congruent consecutive sides. So we look up here, these two sides that are right next to each other are congruent. So we have 1, 2 at the top that are congruent, and then we have down here we have another two pair of sides that are congruent, that are right next to each other. So the opposite sides aren't congruent, but the two sides that are right next to each other are congruent. Again, just like a rhombus, the area for a kite is 1/2 diameter 1 times diameter 2. So in this case, it'd be equal to 1/2 8 times 6. Half of 8 is 4 times 6, which would equal 24 centimeters squared. Kite properties is when we draw our diagonals, one of those diagonals gets split in half. It's pretty obvious it's this horizontal one that's going to get split in half. So one diagonal is an angle bisector, which is just going to be this vertical one here. So it's going to split the bottom angle in half, and it's also going to split the top angle in half. And finally, diagonals are perpendicular, and we draw our diagonals, and they're going to form this nice right angle here. Alright, those are our properties for our different quadrilaterals. Now on your homework, you kind of got a little murder mystery here. So we have all of our suspects, and we know that the murder happened in the library, so you got to figure out who was in the library ultimately, but you also need to figure out where the other quadrilaterals were at in the mansion here. And you're going to use our clues, so using our properties that we just talked about, to figure out who was in which room. Alright, that's all I have for you guys.